And we're going to start with some notes today on 4.3 molar mass. All right, so we're going to, just for a second, reference the video from Friday that we watched on the mole and where that all came from. And while that video may or may not have made much sense, it was at least an introduction to the concept of the mole. Avogadro is where we get this concept from. And the nuts and bolts of it are those last two stated that lines. Remember, just like a dozen is 12 things, a mole is 6.02 times 10 to the 23rd things. And for the purpose of today, maybe the most important part of this is what the mole means. The mole means we can relate the number of particles of something to the mass of something. And again, if we were going to do a lab, I wouldn't send you back to the lab and say, hey, go grab 38 particles of iron hydroxide. You would never do that. But I would say, hey, go get 5 grams of a substance, some kind of mass. That at least makes some sort of sense. And again, those last two lines are kind of the important part of this. Mole is 6.02 times 10 to the 23rd particles of something. And lastly, the mass of that substance in grams is 1 mole of the substance. Once you get done writing this out, please get out your periodic tables. You're going to go back to needing the periodic tables. While you're doing that, you might as well dig out your calculator. Remember, starting now, calculators need to be brought to class along with your notebooks every day. If you did not remember your calculator, you can use your phone, will work for today. We're not doing any big math today. But a calculator would be a better option. So get those out once you get this written down. So today's concept is molar mass. Now, to use and figure out molar mass, we need your periodic tables. What we are going to use for that is the average atomic mass listed in the box for every single element on the periodic table. Okay, this is not the atomic number, this is the atomic mass. The average atomic mass for any given element is what we are going to need. Now the beauty of that is, on Friday we passed this around. This is a 1 mole sample of copper. Now because it's 1 mole, how many particles of copper are in this?
Whatever the mass is.
Particles, though. Yes, that giant number. There are 6.02 times 10 to the 23rd particles in this little bar of copper. Okay? And now here is the secret sauce to Avogadro's number. Not only do we know how many particles, and when we're talking about particles here, if we're talking about copper, what do we mean by particles? Atoms, right? We're talking about copper, so we're talking about atoms here. Here is the secret sauce. I do not need to put this bar onto a scale to figure out the mass. I know what the mass of this is. The mass of this is the average atomic mass in grams. So what's the average atomic mass of copper? Look on your periodic table. 63.54 or whatever. So I know if this really is 1 mole of copper, I know the mass of this bar is 63.546 grams. That is the molar mass of copper. If this is 1 mole, that means it is also 6.02 times 10 to the 23rd particles, and it is also 63.546 grams. That is the secret to molar mass. You can look up what a mole is of any element by simply using your periodic table and looking at that number in the box for whatever that element is. So how much mass would be in 1 mole of calcium? 40.078 grams of calcium. And we could do that for every single element. Now we're going to talk about, for just a moment, rounding. Round these molar masses to 1 decimal place. I think Morris rounds them just to the nearest whole number. I'm going to do 1 decimal place in our classes. So what would the molar mass be of oxygen? 16 grams per mole. What would the molar mass be of copper? 63.5 grams per mole. So let's calculate some molar masses of compounds. Molar masses of compounds are just like molar masses of elements, only we just need to add up whatever is in it. So for HCl, this will be our example. First, you list out what is in it. There is an H and there is a Cl. Now again, we're going to go through some steps here on how to do this. Right? And for the sake of learning this, you can just memorize kind of the steps that we do, which you're going to have to do. But we'll also try and talk about along the way kind of why we're doing this. So how many hydrogens in each HCl? How many chlorines? Now we're going to multiply that times the molar mass number for each element. So what's our molar mass for hydrogen? 1. What's our molar mass for chlorine? 35. We'll get to that in a second. But no, that's just the total. Right now we just sum this up. Some of you may be having flashbacks to isotopes. Remember when we calculated the weighted average when we did isotopes? We were doing some averages and some other math with that. There'll be some parallels to that, but not exactly the same. Yes? That's the total. We added these up. So this is the molar mass of HCl. That's how we would read that. The units here are important. Your unit for molar mass is grams per mole. Again, I know it's been, well, gosh, months maybe since we've been dealing with numbers that have to have units and everything else. We're back. Yeah, T-charts are coming soon, but it'll be a hot minute for T-charts. So let's do another one. What was that other one on that slide? Sugar? So let's do this one also. First, you just list out what's in it. Next, we total them up. How many carbons? Hydrogens, oxygens, and then times their average atomic mass. And again, these are just numbers you look up on your periodic table. You'll start to get real used to some of these that we see all the time. We're going to multiply these out.
96?
I'm going to total them up. 0, 1, 8. So the molar mass of C6H12O6 is 180 grams per mole. That's what you need to be thinking in your mind when you're looking at this. So just for the sake of putting this all together, if I had a mole of this compound, what would the mass be of that compound? If I had 1 mole exactly of C6H12O6, if I had 1 mole of it, what would the mass be? 180 grams. If I had half a mole of this, what would the mass be? 90. If I had whatever number of moles of this, I could figure out the conversion to mass, could I not? Ben?
So if we just got 100 grams of sugar put together, that would be 1 mole.
180, yes. More useful, and what we'll do next once we get through with this will be you're going to weigh out some amount of this compound. And your mass on that will be 53.8 grams on the scale. You can then figure out how many moles that would be. Some, 0.48 moles, whatever. So let's keep going. Just when you thought it was safe. The next thing we're going to find out is percent composition. We'll put a little line in your notes, the next heading, topic, whatever. You're still in 4.3. This is percent composition. So what we're going to find out next, and HCl is the first example that we're going to do, but we're going to say, all right, if I have some sample of HCl, by mass, what percent of that is hydrogen and what percent of that is chlorine? Right? Will it be 50-50? Why not? Yeah, yes. Hydrogen is the lightest element, right? And chlorine is not. Chlorine is much more massive than hydrogen. Right? So let's see how we figure that out. So we start with the exact same process that we had before. You have to figure out the molar mass of that compound first. And then how would we find percents of each of the constituents in that compound?
You would divide that amount by all of it.
Yeah. What is percent, right? Percent is just a portion of a total. Well, this is our total, and these are our portions. Not 2. Divide by the total. Remember, this is like weighted averages back in isotopes, right? The average mass of HCl, the average part of that that's H is much, much less than the portion of that that's chlorine. So you take the individual masses of those elements and you divide that by the total.
What do we round to? What, like that?
Same thing, a decimal point or so would probably be fine. So what do we get when we divide 1 divided by 36.5? A small number, yeah. How small?
Well, it's 2.7%. 0.027.
0.027. And then the other one will be point. And then to get these to percents, what do we have to do? And 97. Again, this is not complicated, crazy math. This is just percents. This is a little bit of dividing, a little bit of adding, a little bit of multiplying. But we're using this to apply it to some kind of concept, right? So if I had 100 grams of HCl, I could tell how much in grams of that is hydrogen and how much of that would be chlorine. Everybody got this?
Yeah.
Guess what's next? So given this starter point, how would we move to figuring out percent composition of this compound?
72 divided by 188.
Yes, divide all of your numbers by your total. Now I skipped a step in there and went right to the percents. I did the multiply by 100 in my head because it's just moving a decimal point. Now, what do you note and what's important about the total here? Always going to add up to 100. Now, maybe it's 99.9, maybe it's 100.1, but these should all add up to 100. Depending on a rounding error, you might be a little bit off, but they have to equal out to 100. This is an important check step. I would always check these to make sure they add up to 100. Again, guys, we're back in math mode here. And in the case of doing these problems, you're going to have to multiply, divide, you're adding, you're doing a bunch of things on your calculator, and all with sometimes decimal numbers, whole numbers, whatever. So if you are doing that over and over, and you fumble on your calculator somewhere in here or somewhere in here, you need to check that. That's why you check those things. Make sure these add up to 100. Because if they don't, and it's probably just you mishit a number in your calculator, again, there's going to be a lot of numbers, a lot of hitting buttons on your calculator here. All of those are chances for error. So if you add these up and you get something that isn't right at about 100, you know there's a mistake somewhere in your calculations. Now, because I can tell you guys are excited about this, we're going to do a worksheet. All right, I dare you. We are going to do a couple of these together. Man, did she take...
days from now, thinking whether they're coming out at the end of the year. She definitely does. She always has both on her.
So, number 1,
Iron sight, horizontal grip.
looks like this. The parentheses here are for you to write the name of this compound. We are going to continue reinforcing previous lessons. So you need to use your periodic table and come up with the name of this compound. What's our next step? How many calciums? How many carbons? How many oxygens? What is our atomic mass for calcium? Carbon is 12, oxygen is 16. For the purpose of this worksheet, we have already calculated what number. What answer is this on your worksheet? First one, the m.m, molar mass. Make sure you include the unit. The molar mass for calcium carbonate is 100 grams per mole. And now that we have this, can we calculate the individual percents? Because I am a math whiz, who knew calcium carbonate was so easy to do the averaging? So calcium carbonate is 40% calcium by mass, 12% carbon by mass, and 48% oxygen by mass.
What are you laughing at? Did you look up? Did you calculate it?
It's just math. So if you're looking at this so far and saying, wow, this is pretty easy, that's great. And I agree with you. There's nothing tremendously difficult about this. But again, we've run into something where there are several steps you kind of have to do in some sort of order. Kind of want to understand what exactly this means and why we're doing this. But ultimately, there's no magic here. Let's do number 4 together. Go down to number 4 and start with, it gives you a name. You need to figure out the formula for that name. Iron 3 carbonate. Write down the formula for iron 3 carbonate on your papers on number 4. You may use your periodic table.
It's on the first column.
Good. And then once you have the formula figured out, go ahead and go through the steps to find molar mass and then also the percent composition. Hold on before you go further. I want to fix that. It's not quite right. Good. try number 4. But I know, that's fine. That's fine. All right, so what is my formula for iron 3 carbonate?
55.8.
So again, if you are not here, if you are not able to get to this, you're going to have a bad time. This is from 2 units ago now, where we were naming and figuring out formulas of compounds. But you need to be able to get to this spot and do this flawlessly every time. Now again, this goes back to, all right guys, stay with me. All right, so this step goes back to October, and now we're just counting atoms in a compound. So how many irons? 2. How many carbons? 3. And now how many oxygens? 9. Remember the way this works. This is distributive and multiplicative. So the 3 applies to 3 of the oxygens, that's 9, and then the 3 applies to carbon, that's 3. What's our atomic mass for iron? I don't break table in my hands. 55.8. Carbon is 12. 16. So again, your molar mass of iron 3 carbonate, 291.6 grams per mole. And then to find percents, we just come in here and divide all these by 291.6. 6. And from there, figure out our divided by. And again, I would do a check step and just make sure this adds up to 100. Pretty sure it does. For homework tonight, finish this sheet. Follow the steps.